Today is the day that we change from particles and meshes, and we're going to be talking about ribbons. Because ribbons can do some really cool stuff. But what even is a ribbon? Well, let's make a new particle emitter here. So we're going to go into effects and we're going to make an emitter. It's going to be an empty emitter to start with, and we'll call this our ribbon emitter or something along those lines. Or a Biron emit. That also works. I cannot spell to save my life. Anyway, we've got our sprite renderer here that we are fairly familiar with at this point. And we can put in our emitter update, we can put in a spawn rate, we've gone over all this, and spawn in like 10 particles a second, and have those spawn in with a velocity of some sort. We fix this issue to add velocity forces. Let's send them up in that direction, and then in particle update we're going to add a gravity force, and now we've got this very sad little particle drip effect, right? And we can increase the initial velocity a little bit so that we have like a little bit more of an arc going on there. And that is all fantastic, but what does this have to do with ribbons? Well, I'm going to add a ribbon renderer to this because I think this is going to be the best way to show off what a ribbon renderer actually does. So let's add a ribbon renderer, and in the initialize particle, I'm going to set the ribbon attributes, the width mode, to direct set, and I will increase the width. And you can start seeing there is a line going through all these particles at this point. So what is actually happening here? I'm going to disable the sprite renderer so that it only displays the ribbon renderer. And what the ribbon renderer does is it takes all of the particles in existence, and that is why you can see that it's a little bit like freaking out here, because it spawns in a particle, and then it spawns in a new particle, and a new particle, and a new particle. It connects all the living particles together, by default from newest to oldest. So again, as it spawns in new particles here, the start of the ribbon gets reset and gets reset and gets reset and gets reset, and that's why it's a little bit weird like that. Now, you can change the drawing direction here in the ribbon renderer itself. We've got sorting, which by default is front to back, which is, again, the newest particle to the oldest particle. But we can also change this to back to front, which actually just kind of looks the same. But if you have a specific material which is orientated a specific way with the UVs, this might matter. It might not. For the most part, you can probably leave this alone, but it's good to keep this in mind. We have a couple of other things here, like the mode, which is automatic, custom, or disabled. This is the ribbon's tessellation. So the way this works is, even if we have very few particles, because we're only spawning like 10 a second right now, if we get that down to like 2 a second, you can see it's a little bit more jagged, but if we turn on the sprite renderer again, there still is some curvature in between every single one of these particles. And that is because it's being tessellated, meaning that it's getting extra like geometry added to it in order to render more smoothly. We can set that tension of that curve to being much higher so that there is no curvature there and it's actually only straight lines. So at a value of 0, it's a very smooth curve, once it has enough particles to make a smooth curve, and at a tension of 1, it is just a straight line. You can also change the shape from a plane. We've got multi-plane as well. You've got a tube, which that one is actually potentially interesting. It looks pretty much the same though, if I'm being honest with you. So for the most part, setting this to plane is probably all that you need. Now that we understand a little bit more about ribbons, I'm going to get rid of this spawn rate, and we're actually going to spawn per unit. We talked about this a little bit before, and it was really hard to really show off how this is useful and what this does. But now that we have an understanding of ribbon renderers, let's apply this and make this into a particle system instead. So we create a new Niagara system. If we put that into the world, you can see every time we move a certain amount, and I probably want to decrease the velocity and the gravity force as well for the sake of this example. But now every time we move in, I think by default 20 units, it's going to be spawning in a new particle, which means that's actually quite nice. Now, probably want to space this out more like 250 units, or even up to 1,000 units, whatever. And now back in the viewport, if we move this particle system around, you can see as it moves, it spawns in new particles. It's a little bit weird in the viewport itself, but if you end up like parenting this to, for instance, a sword, or like a character that moves around as like a speed trail or whatever, that's the kind of thing that this is really, really useful for. It will behave a little bit better than dragging it around in the viewport. If we simulate here, it will also behave a little bit more smoothly, but you can see this is how we spawn in these particles over a certain distance. So that's quite cool that you can use that kind of thing. Now that we understand this ribbon renderer properly, as well as having gone over the spawn per unit, we're going to talk about beams, because that is something that you're going to combine ribbon renderers with quite often. So let's, for the most part, just stick with the sprite renderer as I explain what a beam is and how we can spawn it in and how we can set it up, and then we're going to change over to the ribbon renderer for the actual result that you might want to be looking for with this kind of thing. So in emitter updates, we can add a beam emitter setup. We do this in emitter update because you can, if you want to, change this throughout the lifetime of your emitter. And this is going to take in a beam start position, which by default is just 0, 0, 0 in local space for this particle system. And that is going to take in a beam end position. For now, let's just set that at like 150 to the X. You can also do it in the Y, in the Z. You can do some interesting stuff with this. Then when we spawn particles, we're not going to spawn in a shape location or whatever. We're going to be spawning in a beam. So spawn beam. That's going to take in the beam emitter setup that we have here and spawn in particles on it. Of course, we don't have any particle spawning set up at the moment. So let's go back into our emitter setup. And for beams, you really only ever want to use spawn burst instantaneous. And that is because if we do that, you will be able to see we spawn in one particle. That is a little bit too little. So let's spawn in 10 particles. There we go. We can now see these. It spawns in the particles all at the same time across the line that you specify for your beam, which is going to be useful in a moment. Trust me. In much the same way that in a shape location, if you want to evenly space out your particles across the space, that only really works when you spawn them all at the same time. Because if you're spawning all the particles one at a time, it's always going to, well, evenly spread them out over the beam in the context of every single particle on its own. So we can just show you how that doesn't really work. If we set this to a spawn rate instead, it's going to, let's set this to like 15 particles per second. It's always going to spawn every single particle at the 0 position, because it's not taking into account the particle that previously spawned or anything like that. It's just going to be spawning at the 0, 0 position. So for beam spawning, you want to use spawn burst instantaneous. As you can see, it spawns them all neatly in a line. And again, as we just talked about, that's exactly what a ribbon renderer will show you. So if we disable the sprite renderer here and we enable the ribbon renderer, we can now see, hey, we effectively just spawned in a line. Now, the default material here for these lines is a little bit, how do you say it, boring. So let's maybe go into our particle update and we can scale the color, right? And we're going to scale the color with RGBA in linear color curve, and we're going to set the alpha here to a value of 1 as well, so that it doesn't necessarily fade out as much. It still does fade out, and that is to do with the material itself, I believe. So yeah, this material specifically also fades out the texture coordinate. So you can make a separate material here. I'm just going to get rid of the texture coordinate fade because I don't want to be using it. Don't change this material in your own project, because this is a great default material to fall back on for ribbons. Just make a separate material that only does this, right? For now, we're just going to stick with this change material because do as I say, not as I do. And now you can see it doesn't at all fade out. It's just a white line, which is quite neat. So let's do something with these colors. We're going to maybe start at a blue color, and then we want to add a magenta color, something that is nice and different so we can see it. And this is just going to change over the lifetime of this entire strip. So the strip as a whole is now changing its color, but that's not exactly what I wanted. What I wanted is actually for the strip to start over this side blue and then gradiently change into the magenta color, not over a lifetime, but instead over the distance. And the reason that it's doing it over the lifetime is because we're telling it to, right? We've talked about this in a previous video, and that's this curve index. That is the value that talks about like this direction, that's a very straight arrow, of your curve, or in this case your gradient. And that by default uses the normalized H. So let's take a look at what else we can use. There's a bunch of different stuff that we can use here, but what we want to be using is the link order. So this is for the ribbon. We can use the ribbon link order. There's like 3 different ones of them. I believe we want to be using this one. So now you can see where the ribbon starts on the right hand side, the first particles that spawn. Well, they all spawn at the same time, but they still do have a order that they spawn in. And so now here we have a gradient in which we can actually just put in other colors as well, right? If we want to say, actually halfway through I want you to turn green, and then I want right over here I want you to turn like a little bit white for a moment, we can start making this little color strip, which is quite nice and quite fun. In the particle update we can also scale the ribbon width if we wanted to, and here we can get float from curve, and there we can, again, this is over the normalized H, so it just shrinks down. Once again, if we use the link order instead for the ribbon, now we can really quite nicely say, okay, at the beginning of your lifetime, or the beginning of your link order rather, you are very wide, and at the end you are very narrow, and that's how you can do that very easily. And you've got these like very standard looking curves that you can use, which are all nice. This is quite nice, but since we're working with a beam spawner, which is a very specific spawner to do this kind of thing exactly, Unreal actually offers us some tools to do this specifically with beams. If you have simple different particle systems that don't use beams but do use ribbon renderers, this is the way that you would do it. But since we're working with a beam here, we can actually get rid of the scale particle ribbon width thing here, and what we can do instead is in the particle spawn, when it spawns, we can set the beam width. And that effectively does the same thing. So we can set the beam width. We also have a twist amount, which is quite interesting. But we're going to ignore that for now. And we can get a float from curve here. And again, this more or less just kind of does the same thing. We want to set this to the link order. But now it's setting that value specifically to do with the beam. As far as I'm aware, they're fairly the same thing. I'm just giving you both options because this works with a beam, and this is the way that the Unreal particle systems themselves do. Like the beam template that they have, they use the beam width and then also an update beam function here. So that's a good way to do it, but that only works if you're spawning in a beam. If you have a ribbon renderer on something that's not a beam, you're going to want to do it the way I showed you. But I personally think it's just better to scale the ribbon as like a standard workflow, so you don't have to think about it too much, because I don't know that the beam width module itself has much else going for, other than of course this beam twist amount, which is actually like quite interesting. Because if we also get this from a curve, which we're going to take the link order, which we will just like copy and paste over here real quick to get that value. Like you can twist this beam around a little bit, and that makes for a potentially interesting effect that is something that you can really only do with the beam renderer. I'm sure that you could replicate it some other way, but this is an easy way to accomplish that. So for this very specific effect, using the beam width is interesting. Otherwise, I wouldn't worry too much about it. Now, the one last thing that I want to show you, because it's a often shown and used effect that is quite easy to set up and quite easy to make with ribbon renderers, and that is let's get rid of this beam width real quick. and we're going to set this to scaling the ribbon width again, because again, that is the way that I prefer to personally do it. Your mileage may vary. So let's paste in that value for link order again, and we've got that going. What I will do is I will add some keys to this. So what I want is at the beginning and the end, I wanted to have like a pretty sharp like cutoff, but everything else should be decently straight. And then we can go back into the initialized particle and set this to a significantly lower value again, something like 5. And we've got something a little interesting to look at, like almost like a lightning bolt kind of shape. And that's kind of what we're going to be doing here, because in the particle update, what I am going to do is I'm going to jitter position, and you will see that that does exactly that. It just jitters the position of every single particle around. Of course, we want to jitter this a lot less. And here we get into a little bit of fine-tuning, because they are getting really far out of place, and that is because every single update, it's offsetting every single particle into a random direction, and that kind of makes all the particles float apart. Again, if we turn off the ribbon renderer and we go into the sprite renderer, you can kind of see what that does. It really starts like pulling all these particles apart. The way to fix that is just to go back into initialize particle and set our lifetime to something much shorter, something like 1 second instead. Now, after a second, that does mean that they will die. And the easiest way to fix that for preview purposes is just to pull this timeline red flag over here all the way back, so that it like properly loops around a little bit better. So there's still a little bit too little detail in this, and that is because if I set the sprite size real quick to uniform and I scale this to like 2, and I set the sprite renderers to being on again, these are all the points that the ribbon can work. There's not much more to it. Also note, by the way, that it's not just the ribbon that gets colored, it's the particles, the sprites themselves get colored as well, based on the scale color still, so that's quite nice. But if I go back into spawn burst instantaneous and I set this instead to using 50 particles, let's go back to the ribbon renderer and see what happens. Like, we have a much more like detailed wiggle in this. It's still not exactly looking like we want it to look like, and it's partly because 50 is just too much for this. So that's like 20, maybe 30, it'll probably be enough. And here we start tweaking values. I'm going to jitter amount a lot more, and then we're going to go into initialize particle and make them live a lot shorter. And we're also going to be setting the ribbon width to something even small. Now, there's one last issue that I really want to take care of in this, and that is the fact that the ends also move all over the place, and we don't actually want that. So we're going to set the jitter amount to being taken from a curve, and by default, of course, that's going to take the normalized age, which means that they're going to start out not wiggling a lot, and then as they get older, they wiggle more and more and more. That's not exactly the way that I want to do it. What I want to do instead is I want to, of course, use the link order here for the beam, meaning that at the start and the end I want them to not move at all, but then I want to add 2 extra keys, one there and one there, where they start moving. So now if we play this, and I think I set the lifetime to 0.2 or something like that, so you can see the beginning and the end now don't move, which for like a lightning kind of effect feels a lot better. I want this to be a little bit more emissive. So we have this scale color. It's a little bit annoying to increase the values on one of these gradients. And the easiest way to fix that is, instead of using the scale color, we can go into particle spawn and we can just add a color node, and here we can say, hey, we've just got our normal color, but we can get a multiply linear color instead, which will just give us our tint that we want to apply to this. So we can tint the entire thing like more blue if we want to, and then everything is going to be tinted more toward blue. We've talked about this in the past. This is just going to stay white for now, and the scale factor, we want to get our vector 4 from a float. So it's just going to be one value. If we set that to something like 10, you can see that it starts being more emissive. So maybe even something like 50. And now it starts to feel like a rainbow colored kind of lightning strike. And we can keep going back and forth between all these things, because now I feel like, maybe actually we do want to have a couple more particles in the spawn count to have it be a little bit more chaotic. And if we add in more particle spawns, maybe what we want to do is we want to set the jitter position to a slightly lower value, so something like 0.7. And you can keep tweaking this endlessly until you get the values that you want. But those are the basics of ribbon renderers and beam spawners in Unreal Engine. It's quite important to note, because oftentimes, otherwise, what you will end up doing to create something like a line is just spawning in a bunch of tiny square particles, hoping that they roughly form a line, which is just not great to do it that way. So hopefully this has been helpful. Next time, we're going to be moving on with making particle systems a little bit more customizable using, which you can see here in the bottom left corner, parameters. And that's going to be a very interesting one. So I'll see you all back then. And for the full course, if you're watching this in the future, it should be all up on the YouTube channel already. But if you're watching this shortly after it was uploaded, there will be a link down below in the description to the Patreon where you can find the full course. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page. A huge thank you to my Cave Student tier supporters, Earl Monseval Erno, and my Cave Digger tier supporters, Sergey Thomas,